Well, let me welcome you to the Cal Homecoming, and also this is the 39th annual S.J. Hall Lectureship in Industrial Forestry. So thank you for coming out on this rainy day. It's actually kind of a nice day for those of us that like a little bit of rain. I'm Greg Bigging. I'm an Associate Dean for Forestry and Cooperative Extension in the College of Natural Resources here at Cal. And it's my pleasure to welcome you, as I've just said. And before we begin, what I'd like to do is recognize the Hall family. And actually, their generosity makes this lectureship possible. And the Halls are here. And I'll just point out a few of the people. We have David Hall, Dorothy Hall. We have their son, Kenneth, and we have Susan Hall here. The Dean of the College, Keith Gillis. Over on the side, we have Peter Burke, who's the holder of the S.J. Hall Chair in Forest Economics in the Department of Agricultural and Resource Economics. And also last year's distinguished speaker in the Hall Lectureship, Bill Berry from ITT Rainier. So what is the S.J. Hall Lectureship? Basically, it's a series which began in 1969, and it's named after the late S.J. Hall. And he helped establish Guala Redwood Company, perhaps you've heard of them, just up in the north, up in Mendocino. And Hall became a leader in the industrial management of young growth redwood forests, and he established something that's known as the Forest Economics Foundation. And one of the things they wanted to try to do is to make sure that forestry students in colleges, both in the US and Canada, would really practice sound economic principles as part of their management of forest enterprises. So that's the genesis of this lectureship, which we've been holding since '69. So now it's my pleasure to introduce today's speaker. We have a very distinguished speaker here, Dr. Ian de la Roche. He holds a Bachelor in Science degree from McGill, a Master of Science degree from the University of Massachusetts, and his PhD from the University of Illinois. He's published over 75 articles, many in the area of plant genetics, physiology, and biotechnology. He began his professional career in the 70s working as a scientist, and then later as a senior research manager with Agriculture Canada. And during that 20 years of work in agriculture, he played a very prominent role in promoting commercialization of new technologies brought about by collaboration between industry, government, and universities. Then in 1992, he joined the forest sector when he was appointed president of Forestry Canada Corp. In 2004, he assumed the responsibilities of FERIC and more recently Paprcan, and I will explain what those are in just a second. In September 2006, he was appointed president and CEO of FPInnovations. This is just to show you their website. He brings over 30 years of experience in research, strategic planning, and creation of partnerships between state and industry to this new institute. FPInnovations is comprised of three primary divisions, which are listed up here: FERIC, Forentech, and Paprcan. Those are all acronyms. FERIC is the Forest Engineering Research Institute of Canada. Forentech is Canada's National Wood Products Research Institute. And Paprcan is the Pulp and Paper Research Institute of Canada. And FPInnovations also has oversight of the Canadian Forest Service Fiber Center. So it's a very interesting and very comprehensive grouping of divisions that FPInnovations has oversight and control of. Now, these four units and staff have approximately 675 staff and an annual operating budget of approximately $100 million. And it really makes it the world's largest private forestry and forest products research institute. I want to mention one thing that Dr. de la Roche has been working on since 1992, and it's involving academic institutions in China and industry and government there. And Interestingly, he holds an adjunct professorship at two of the best forestry universities in China, Nanjing Forestry University and Beijing Forestry University. And his scientists have been actively engaged in the development of the Chinese timber codes for wood construction, and they have similar projects of development and research going on in Taiwan, Japan, and Korea. So please join me in welcoming our distinguished and accomplished guest, Dr. Ian de la Roche. His talk is entitled Forest Products, Part of a Sustainable Future, and he'll be touching on some issues in this, such as what will be the role of forests in meeting energy demands, and how will this affect the environment. So Ian, thank you. Thank you very much.
Thank you, Craig. Those are incredibly kind words. I'm a little humbled by them. I will say that I came down this morning from Vancouver, and no, I didn't bring the rain with me. It had already started. I was on the tarmac in Vancouver for about almost 2 hours because flights weren't coming into San Francisco. So I was a little worried that I wasn't going to make it on time, but fortunately all went well, and I am here. And it's particularly great for me to be here on this particular weekend with Cal Homecoming. And I came close to being a student, a graduate student here in Berkeley back in the 60s. As Craig mentioned, I just finished my master's at the University of Massachusetts, and I was fortunate enough to have two opportunities, one at Berkeley and University of Illinois, and that was really my short list as a top choices to go on for a PhD. I finally settled on Illinois, and I moved from Massachusetts, from Northampton area, into Champaign-Urbana in the summer of '66, and that was the summer of love, and all kinds of neat things and not so neat happening around the Berkeley campus at that particular time. But here I was in this I was actually corn breeding, so I was out in the field all summer, working in a very kind of conservative, Midwestern, almost uneventful environment, and getting the snippets of information by television, what have you, what was happening here. And I can honestly tell you, if I've questioned anything in my life, it's really, why didn't I come here instead of Illinois? I was, however, very fortunate to be able to sit on an advisory board at UC Berkeley's Forest Products Lab for 10 years. And Frank Beal and a lot of the board is here, actually, and I'm pleased to see that. This gave me the opportunity to come back to Berkeley often 2 or 3 times a year. And so while I'm not officially an alumnus, I do feel a particularly strong attraction to your university. Hence, I'm really overjoyed when Craig called me and said this was an opportunity for me to come down, and I just grabbed it right away. I'm going to talk to you today about various things, and Craig touched upon them, but I'm going to leave you with my conclusion right now, and I'll come back to it, and hopefully my talk will reinforce this rather simple message. And that message, quite simply, is that the current rate of consumption of non-renewable materials, land, fresh water, air, energy, are not sustainable in the longer term. And this, I think, is giving us the opportunity to move towards a new bioeconomy. And I believe that this new bioeconomy will be based on renewable lignocellulose from our forests. And this, I think, is going to do some pretty exciting things. It's going to create a whole array of new product streams, new applications, but more importantly, I think it's going to allow us as a sector to regain prosperity again. My talk will be broken. I should be following these slides. Okay, that's just a statement of what I just said. An outline of my presentation. I'll first take a brief look at the long-term trends, as well as talk a bit about the myths that are associated with wood, with forest, sustainability, etc. And then I'll move on to talk a bit about Canada and how we're trying to address the issue around sustainability of our forests. I'll then introduce FPInnovations and how we are attempting to help the sector re-engineer or transform itself. And then I'll end by presenting you a few examples of the kinds of exciting products and applications that can come out of cellulose, that really incredible complex molecule. Let's look first at the long term. We know the impact of globalization is hitting virtually every aspect of life and economies around the world. One that I want to focus on is the growing consumer demand. I also want to turn to the depletion of the planet's non-renewable resources, and as a third trend, look at the growing impact of human activity on climate change. The world's population has grown since 1950 from 2.6 billion to 6.9 billion today. By 2050, we can expect to see a world population of about 9 billion people. That phenomenon, coupled with what I would say the voracious appetite for consumer goods in rapidly developing countries like China and India, is placing enormous pressure on the planet's natural resources, the non-renewable ones. In fact, when you really look at it, today China and India combined represent 38% of the world's population. I've tried to depict these shifts more from a macroeconomics or supply-demand curve in terms of natural resources and the ever ongoing decline over the ages as we've seen the increase in population. And on the x-axis, I've tried to show some of the transformative events that have been occurring. And the thing I want you to focus on is that in all of these, green revolution, electronic revolution, industrial revolution, technology and innovation have played a very critical role. And not only that, as it's gone further along, the knowledge part has become more and more significant as a component. In fact, when you look at this, in the earlier phases, land was replaced by labor, labor by capital, and capital by knowledge. We're at the tipping point now as a country. This growing population, this growing demand, this decrease in the non-renewable resources have put us at a tipping point. And this is where I believe we're going to see the second green revolution, an environmentally sustainable one that's going to drive the new bioeconomy. So there's a couple of questions we have to ask. Can we, as individuals in North America and the world for that matter, recognize the value of where we can go in terms of using renewable resources as our main feedstock to feed, to clothe, to heat our homes? And are we willing to embrace this as an opportunity? And the second thing, is human ingenuity and innovation going to again defy the Malthusian arguments or theory that with population growth, you automatically will get scarcity? And as we know from this, that is not necessarily the case. What about climate change? That was the third trend I wanted to address. Well, I believe, as I'm sure all of us in this room do, that climate change has really coalesced public concern about the carbon footprint of all, and I stress all, human activities, products, and processes. The DiCaprio film, 11th Hour, Mr. Gore's activities, etc., are just a bellwether, I think, of a global feeling and movement towards that. And we have some challenges in our sector. If we look at the primary causes of climate change, global warming, we see very clearly that deforestation is a major one. In fact, deforestation in agriculture, as you can see, amount to a considerable percentage of the CO2 emissions into the atmosphere. While urbanization is a factor of deforestation, the biggest contributor by far is the deforestation of tropical forests for agricultural purposes. A large part of this is driven, ironically, around subsidies or economics, valuing the growing of energy crops for biofuel. We can stop deforestation. by incenting economic return, by not only growing and reforesting new trees, but also being allowed to cut them in a sustainable way and to make forest products. When we talk about climate change, we can't help but think back with the sad events that occurred with Katrina. But there's equal concern, I think, about the effect of climate change on increasing the biotic and abiotic stresses on our crops and on our forests. Mountain pine beetle is a very good example of that. We have a situation in Canada, in British Columbia, where I live, where this beetle was kept under control in our forests because the larvae didn't survive that much as a result of the colder winters. With the warming winters that we're seeing now, we've seen an explosion in the beetle population, and this has proved to be a real disaster. This is an example of lodgepole pine forest attacked by the mountain pine beetle, this little creature here. And basically, this is within 2 years, year or two. That moves fairly quickly in 5 years to what we call the gray stage. That's dry, desiccated timber. And the challenge is, how do you try to recover some value from that fall down? Because let's face it, if that's not harvested and used into products, it'll either burn or it'll decay, and it will emit CO2. But there's issues around harvesting this kind of material, accessing it, issues around regeneration, and that's some of the work that my institute is actually engaged in. I'm going to move now to what is I thought is a neat depiction of what has occurred and what will be occurred. It's a computer simulation of what's going to happen to British Columbia. And it's quite scary when you look at it. Remember, the first sign of attack of the beetle is a red phase, red stage, then goes to the gray, and death. Here it is here, in 1999. It started in Tweedsmuir Park and grew. We weren't allowed to cut and control at that stage. You can see the gray starting now, quite extensive, moving up. And by 1914, this is 2014, I should say, this is the kind of picture you're going to get. Very scary. In fact, when you look at it, the loss is going to be about 850 million cubic meters of timberland. Put it in perspective, that's equivalent to the harvesting in Sweden for 10 years. 10 years of Swedish harvesting. That's a lot of trees. Let's look at another impact of environment, and that is on shelter systems, which is a basic human need and a basic activity. And if you look at buildings and the impact they have, and I want to mention that no matter what system you have or what you build, all of them will have an environmental impact. The secret is to try to mitigate that and make the environmental footprint as soft as possible. And here's a case where if you take total construction, total building around the world, it actually consumes 40% of the energy and materials globally, 34% of the world's CO2 emissions, 40% of the world's solid waste, and 17% of the fresh water consumption. And I know we talk about energy today, but let's face it, fresh water globally is a really serious issue, and the loss of that. We, a few years back, developed a methodology, software actually, to measure life cycle analysis. And this permitted us to very objectively compare different systems of construction in terms of their environmental footprint. And when we talk about life cycle analysis, we're essentially alluding to the full impact one would have to the whole life cycle of a product or of a system, of a house. And that includes the extraction of the growth of the resource, its extraction, effect on biodiversity, and all of these things have to be factored if it's a forest. It's the transportation of that material, the processing of it, the construction, the occupancy, the demolition, recycling, reusing, or disposal. All of these aspects are considered from an environmental perspective and measured and quantified. So let's take an illustration. And this would be typically a house, wood frame construction, in this case in the middle, constructed here in the Bay Area. The other one is in steel, and the other one would be concrete. Recognizing that even on a concrete house, it would have a wood roof, but I'm just saying it would be predominantly concrete or masonry construction. So if you do a life cycle analysis on those three systems, how do they compare? Which has a softer footprint? Well, here it is here. If you take a look at the indices of environmental impact, embodied energy, CO2 emissions, air toxicity, water toxicity, etc. The green is wood, the blue is steel, and the red is concrete. And clearly, you can see when you compare those three construction systems, wood has the softer environmental footprint. But it doesn't end there. There's a further advantage. And that is the role of wood in fighting climate change. We all know that trees take CO2 out of the air, photosynthesis, to make cellulose. So you sequester carbon dioxide, you store it in terms of the biomass of the tree, and then if that tree is harvested and you build that house, you are actually retaining that carbon in that house structure. And again, if you look at a typical house constructed in wood, between 18 to 2,400 square feet, you're talking about sequestering and storing 28 to 32 tons of carbon dioxide that was in the atmosphere that is now being stored. So when you look at the carbon cycle, you've essentially grafted on a piece on that in terms of the being stored by the life of that particular structure, which could be 70, 80, whatever years. And that's equivalent, to put it in perspective, of 7 years from driving your family car, the emissions. So when you're thinking of your house, and your house is built out of wood, you should think of the renewable components in that house as being a carbon credit. We're lucky in North America on both sides of the border. I believe we're world leaders in sustainable forest practices, and we have a wood culture. And you know, that makes us important in the global carbon balance. Without exaggeration, I'd say we're in some ways offsetting the emissions of others. Now, I don't want to dwell on this, but I want to summarize it because I think it's a terribly important point, because there's a lot of myths associated with wood and wood products. And the point of it is, wood has the softest environmental footprint as compared to other mainstream building materials. It's renewable, which others aren't. It's grown from solar energy, stores carbon dioxide. And when you look at it in terms of occupancy, etc., and maintenance, it's very clear that wood, as compared to other materials, is a better insulator. Well, let's turn now to our forests. Talk a bit about the supply-demand issue with our forests. And here I'm trying to depict in yellow what would be our temperate forests. And you can see it stretch across North America, Canada, and United States. And you'd have your softwoods, of course, your boreal up here and across here, but also your mixed species and what have you. And then Europe all the way through the Soviet Union, Russia into Siberia. When we look at that, and then down in the southern hemisphere, of course, the tropical forests that cut across there. When you look at the total area of forest, you're looking at a 3.9, close to 4 million, or billion, I should say, 4 billion hectares. Russia is the highest, and I must say that that data was 2000, so you've got to, that's the old USSR, so it would be smaller now. Brazil, followed by Brazil, tropical, then Canada and the United States. I'd say North America, when you look at it in that context, is probably combined, Canada and the United States, as having the, well, the largest as compared to, this would entail a lot of, as I said, the former Soviet Union. Well, the question we all would wonder is, are we running out of wood? I've been talking up to now about how we could use more wood. The question is, are we running out of it? These are the trends in terms of demand. There's a couple of points I want to emphasize here. The first one is, as population has been growing, so has the demand for wood. But the important thing to note is, and these are FAO numbers, is the huge amount of wood that is used as fuel. And not that efficiently. This is deforestation or overuse, non-sustainable use in a lot of countries, particularly countries that are underdeveloped, and it's used for fuel, for cooking, and for heating. And those processes are generally of very low efficiency. So it's a point to remember that when people talk about the forests, a large amount of that, more than half, is actually burnt to meet personal needs of people. We know that there's a pull on developing countries like China and others, and this is just a snapshot, a place I visited once, northern China. It's at the border between Siberia and China, and this is a Siberian wood, spruce coming in, beautiful material, into China. And of course, China has become a major, major user of wood products. And I'll talk about the plantation context in a minute. So major consumers. Well, a question you might be posing is, what about the idea of original forests? Where do we stand on that? I showed you deforestation and implications there, but what about just globally the forests? Well, you can see it varies, it's spotty. Actually, Canada's probably still got the largest percentage of original forest, followed by Norway. US, 60% of the original forests. And you get down to Europe, of course, and it was removed because of urbanization, industrialization many years ago. It's on a move to be built up again. And then you have the extremes of Mexico. That's a shot in Mexico, actually. And this is, again, for agricultural purposes, South America and Southeast Asia. So there are major challenges in terms of supply. There's no doubt about that. But can we do anything about it? Can we offset this demand? Can we grow more trees? I believe we can. I believe it's important that we do practice strong conservation in certain areas. But in areas where we're going to have a working forest, where we'll be harvesting, it's important to consider it in terms of reforestation, and it goes further than that. It goes to reclaiming back land that probably was forest, that was deforested, to put back into forest, marginal land that is more appropriately available or should be used for forest rather than perhaps grasslands, etc. And there's efforts in several countries to try to address that, including Canada. The other is the improved forest management practices, and that'll include genetics and tree improvement and plantations, and I'll say a word about each of those quickly. If I look here, this is a recent study done by Jan Frick at Skoog Forest, and they went through and looked very carefully at all the aspects of forest management, of tree improvement, etc., and looked at the point, if you took the Swedish forest today, how much could you increase growth without getting into plantation, but using managed forest as it exists in Sweden now? And the feeling is it's anywhere between 20 and 50% increase in yield. Just improving and using more effectively practices like pre-commercial thinning, commercial thinning, what have you, and using residues. In Canada, we practice extensive forest management, so it's not quite the same system, but we calculated it could be 20 to 40%. So there are ways of actually growing more trees, even on the land that you currently grow trees on. The other thing I haven't touched, I mentioned genetics, but there's the whole area of biotechnology. And it's problematic, but if we can live up or can achieve 20% of what potential has been promised, that could be an exciting possibility. What about plantations? Well, we know in China that's become a state forest administration policy in a very serious way. A lot of it being driven by mitigating erosion and desertification. And of course, those trees are fast-growing poplar and eucalyptus, bamboo, etc., and will be harvested and will be used in wood products. The thing that I would like to mention is the difference in growth rates that are occurring as a result of intensive plantation management and genetic selection, what have you, and comparing that to, let's say, in Canada in the boreal forest. Our mean annual increment in terms of growth rate per year is about 2 cubic meters per hectare. Down in southern parts, South America, they're getting up to 56 cubic meters per year. That's about a 25 times greater growth rate. Well, let's talk about Canada and how we're addressing the sustainability issue, which was the other piece that I wanted to get into. It's actually an interesting place these days because it's a big country. It's probably got the largest concentration of fresh water in the world. Up in the north, the tar sands here are generating a lot of non-renewable fossil fuels, but there's a humongous amount of energy there. And there's all these trees, which are a potential source of energy. So the fresh water, the energy possibilities, the land, few people, I think are kind of neat. And I think it's an opportunity that more and more we'll see us, by us I mean both sides of the border, looking very much as an entity of North America working together on recognizing this and recognizing the value that this can bring. If I look at our land base, it's about 1 billion hectares. If I look at our forest land, you can see it's about half a billion. The productive timber areas, the traditional areas where we would look at harvesting, represent 250 million hectares. And you can see what we harvest down here. 1 million hectares is harvested, which is less than 1% of the productive forest, about 0.5. This is interesting because that 1 million hectares, you can put in perspective of what we lose each year from disease and fires in Canada. It's about 15 million. So it's 15 times the annual harvest is lost that goes up as CO2 in the air. What about conservation? That's, to me, a key issue because we're talking about a balanced approach. Working forests, but also conserving forests for issues around biodiversity and what have you. And if I look at that, Canada is up to 40 million hectares of forests that are protected, that are not harvested. And you can see where the rest fall in. Well, what about the regeneration issue? You can see the numbers there in terms of actual replanting, regeneration. This is where the numbers are, and this is Canada as compared to some of the other countries. Now, you can say, yeah, but come on, you've got a lot more forests, so what's the percentage? The point is it's still very high. And in fact, FAO in their 2007 report acknowledged that Canada's deforestation rate was 0. And again, a lot of it is planted, but a lot of it is natural regen. You're looking here at material that's in the second regeneration cycle. We've got a lot that is third regeneration, particularly on the coast of BC. And so it's a very vigorous part of what we would call our need to be sustainably managing our forests. Certification, third-party certification is a very important consideration. In fact, if you want to be a member of the Forest Products Society of Forest Products Association of Canada, sorry, you actually have to have all your forests certified by a third party. That's either FSC, SFI, CSA, the three that are generally used. Canadian Standards Association is the last one. I'm sure you're familiar with the other first two. That's a condition of membership in FPAC, which is the sister organization to the AF&PA here in America. And if you look at what's been certified, those numbers are 205. I apologize. 207, it's up to 135 million hectares that are certified in Canada, and it's growing. And why do we want to do that? Well, the feeling is that we feel that as we go forward into the new bioeconomy, it's going to be important that we're green the whole length, and that forest sustainability has to be there, and that if we want to achieve an objective that I think we want to achieve together in North America, is that people should look at our forest practices as the most planet-friendly source of forest products. There's an interesting difference that Canada has. It's a bit of an anomaly and makes us a bit unique in terms of our timber ownership. A very small amount is owned privately. Most of it is owned by the Crown, public. And that really creates a different perspective when you look at the forest. You've got to blend in not only considerations that are economic values, but you've also got to be very conscious of environmental values and social values. And so what we look at it is as more as a public-private partnership. And building on this strategy that I was suggesting in terms of environmental friendliness along the value chain, I just want to take a minute to talk about that in a little more detail of what I mean by value chain and the optimization of a value chain. And of course, we're all familiar with, and this is part of let's say, the strategy and the basis or the rationale for the creation of FPInnovations, which I'll talk a little more about in a minute. But basically, when you look at this first of all, from an economic perspective, it's clear that what we're talking about here is a better understanding of what the customer requires in the marketplace, the attributes desired by that customer. In other words, they want solutions. And linking that back to the raw material, the wood quality characteristics. And the idea is to try to align those as much as possible and to then use the value chain as a way of either enhancing those attributes or adding new ones. And if I look then at the environmental, clearly then what we're talking about is sustainable forestry, third-party certification. We're talking about green manufacturing, zero effluents if you're running a pulp mill, or reduced VOCs and what have you, a soft environmental footprint, and then a whole array of green products. And I mentioned wood products as one of them, but recycled paper, there's a whole array of things, and I'll be mentioning a few more in a few minutes, that will be new value streams. But from an environmental point of view, the idea is to have that greenness all along the chain. And then when you look at the social, obviously there, you're talking about the multi-values of the forest, and that's very important. Because they're public, it means First Nations have a very strong claim on them. There's a spiritual aspect of the forest that has to be respected. There's a whole biodiversity aspect. There's a whole use of recreation and what have you, as well as the economic or harvesting part. When you look at it from the middle part of the chain, clearly there you're talking about communities and jobs. And that's important to public-private partnership or to any relationship. And then in the last area, you're talking about meeting human needs for clothing, for heat, for housing, etc., in an environmentally friendly way. So there's a very strong social thread that pulls across that chain, as well as an environmental one, as well as an economic one. And that leads me now to FPInnovations. And I'm depicting here the value chain, all the way from genetics, tree improvement, through harvesting, etc., pulp and paper, market performance, wood products, and then an array of new product streams. And if you look at these institutes that Craig mentioned, having come together and merged recently, in fact, it's only happened, it's April 1, So it's 6 months that we've been together as one. We have FERIC, which is a forest engineering that plays along that part of the chain. We have Forentech that is here in terms of market. You mentioned China, codes and standards. This is an important area on the buildings, et cetera, but there's also the appearance type products, furniture and what have you. And there's a piece of that that actually is interested in wood quality characterization. In other words, matching attributes to the marketplace. You look at the pulp and paper, you've got a similar parallel to Forentech in terms of markets, et cetera, and the fiber characterization. And there's a fourth division. So those are the three institutes, but then there's a fourth one, which is called the Fiber Center. And that's an interesting one because that's a government entity that has been pulled together. And that entity involves scientists from the Canadian Forest Service that are focusing on the economic aspects of the upstream. It only represents about 10% of their total research capacity, but it's an important group and complements very well what we're trying to do here. The other interesting thing is a unique model because these people still work for the government. They're employees of the Crown. But they take their direction for research from the FPInnovations board. So they're not the same as these three. It's another tier, but they're also, so it's part of an integrated program that allows us to approach problems along the whole length of the value chain. And the partnerships, of course, that are important. Well, our employees are a little over 700, and the budget is a little over 100 million. And as I say, it's, for me, quite an exciting opportunity to be involved with this new venture that we've gotten into. Federal government also, to sweeten the deal, invested over the next 3 years between 25 and 30 million new dollars on initiatives that are built around what we call 3 flagship programs that we are the custodian of. A lot of the work will be done at FPInnovations, but also a lot of that will be to invest in universities for partnerships, et cetera. But the 3 that we're looking at, and they're very much bioeconomy driven. When you look at them, new building and living solutions, the next generation of solutions for people's living needs. The next generation of pulp and paper, specialty pulps and papers, and the applications that we can get from that. And finally, this whole area about around biorefinery, around bioenergy and chemicals and advanced bioproducts. That's what that's going to be funding. If I look at it in terms of the building and living solutions, the focus is to move away from selling, being producers and purveyors of 2x4s to providing people with solutions. Here's a solution that we're looking at, obviously, is how do we get an uplift from all that diseased, beetle-killed wood? And one obvious way is engineered wood products, composites, and what have you. And that's just an example of a structural application of strand and glue in terms of an oriented strand lumber. Another example is looking at buildings in a different way. Looking at new design and construction methods, optimizing wood, using wood where it should be used and not using it where it shouldn't be used, and using wood in combination with other materials, hybrid construction. Also looking at opportunities for non-residential applications. And doing it very much recognizing the important green attribute of wood. I call it playing the green card. And basically, what you see here, and this is Oakville, or I'm sorry, not Oakville, Oakland, something that is sustainable from an environmental perspective, but also aesthetically very pleasing. If I look at the second flagship around the biorefinery, energy and chemicals from forest biomass, and we see this as a tremendous opportunity, this wonderful feedstock that we have that is renewable. There's just some other applications, again, of cellulose in terms of rayon. Basic feedstocks. How do we produce these? Well, in a biorefinery. In fact, the first biorefinery was a pulp mill. It meant taking wood, making pulp and cellulose, conventional processes to make paper. Subsequently, we looked at the waste products, the byproducts, lignin, recognized that and hemicellulose, recognized that we could make other valuable or useful materials. Residues like bark and sludge, etc. Energy, chemicals, and what have you. The opportunities are limitless. One of the, I think, quick wins is using waste energy, or waste residues to produce energy as a substitution for fossil fuels on manufacturing sites. Producing syngas, for instance, to replace natural gas in kilns for drying lumber, or in lime kilns at a pulp mill. Cogen. Pellets can be used for heating homes. A lot of it is actually exported to Europe. In fact, the strategy is to be energy neutral by using residues instead of fossil fuels. And most people are now talking about actually being a net contributor to the energy grid with what would be waste residue material. There's major investments all over the world, and I don't pretend to suggest that in these areas that we're big players in a sense, but I cite one example. I mean, obviously in the US, DOE and NREL are major players. EU is putting major investments in this area, as well as obviously the industry. And this is, I think, a great example of one here. I think this is neat. This guy was up to see us, your governor. And by the time he was through with Gordon Campbell, our premier in British Columbia, this was a changed, transformed man. He's all of a sudden the greenest guy going. I mean, it's just absolutely incredible. And it just blows me away. I mean, you know, this guy really has a personality. He really can occupy a room. It's incredible. Anyway, the point I'd make here, and I really appreciated this fact here, that part of that money is going to be looking at reducing the impact of energy consumption in the environment. And I was looking at the list of projects that were coming out of this, and that impressed me a lot. The point I would flag, though, is my old alma mater. And I think the reason that the linkage was made between Berkeley and them, as well as the Lawrence Lab, was the fact that they have a very strong ag capacity at Illinois. And I guess that brings up the other point. You could probably sense it in the conversation that I've been having, is that as an ex-corn breeder, et cetera, and in corn for many years, and I've seen the light now that I see trees, I really question whether this is the way to go, whether it's appropriate to use food for fuel. And we've seen the economic impacts that have happened. China's gone to WTO, riots in Mexico City because of the price of tortillas. I mean, things like this. You know, let's say you had a tiny SUV, not a big gas guzzler, not a Hummer or anything, but a tiny SUV. And you were going to replace all that fuel with ethanol. You know, it would take 2 hectares or 5 acres of corn to supply it for a year. I mean, that's a lot. And when you start extrapolating, if in America we were going to take 10% of our fuel for automotive and transportation and have it as ethanol, you know, you're talking about 43% of the current cropland in America, or 38% of the cropland in Europe. It's a challenge. So what's the solution? In my mind, it's a balance. It's a balance of various options. Obviously, this is an immediate option that we have in the non-renewables. But there are opportunities to conserve. There are opportunities to increase fossil fuel efficiencies, and we're seeing that now. And in fact, California is leading the world in terms of trying to put that in and from a legislative point of view. And there's also the opportunity to restore working forests. And then, of course, we get to the long term, which is lean or zero carbon. And that's fuel cells, nuclear, tidal, hybrid, wind power, etc., other alternatives. So I think what we really should be looking at is a blend of all of these factors, a balanced blend. I want to turn to some of the other exciting products that I see coming down the pike, and this will be sort of wrapping up my presentation. Based on cellulose, you know, the annual production of cellulose, cellulosic material, is about 1.5 trillion tons per year. There's a lot of material out there. It's a very exciting, interesting molecule. It's a straight chain polymer, extended rod-like conformation. It aggregates into microfibrils, held together with hydrogen bonding, giving it incredible strength properties. Here's an example of one application that might happen. It's not a dream, I think it's possible. These are some South Korean scientists that are actually working with NASA. Therefore, that piece on the robots, et cetera, you can guess what that would be in terms of drones to fly around to check for gas, et cetera, things like this. But this is dissolved pulp that's been formed into a sheet and then coated with a layer of gold to act as an electrode. They're lightweight, and when you apply low voltage, and you only need low voltage, you get a very high degree of deflection. And these things can deflect and return and actually do the process quite rapidly. So you can see the applications there, as I mentioned, robotics, chemical sensors, visual displays, even artificial muscles might be a possibility. Here's another one. Rensselaer Polytech. This is nanocomposite paper, and this is a paper battery. It can function as a lithium battery or as a supercapacitor. It uses carbon nanotubes that act as electrodes. It's infused within the cellulose, so you get the separator, and then you got a lithium oxide coating on the other surface. The black surface would be the carbon face of the carbon nanotubes. And with that, you've got power. And the interesting thing about it, because it uses ionic liquid electrolyte that's soaked into the cellulose, it can have this it's very robust at temperatures up to 300 Fahrenheit, down to minus 100. So it's kind of interesting, those kinds of things. And it leads to another one that I'm really excited about because it involves FPInnovations. And this is bioreactive papers. And the thing about that is that this would be a specialty paper. And it's a paper at the nano level that's been constructed that can allow you to detect, repel, and or deactivate pathogens. The SARS mask is a little bit of a hype thing. I mean, I think perhaps you could really see the applications in food packaging. Wouldn't it be nice to not have to pick up a package and say, what's the expiry date? This could visually change, so you'd see if the food was off. So that's quite exciting, and those are some of the applications. Another one that we're quite excited about is the whole area of nanocrystalline cellulose. And Paprika, before it became FPInnovations, for many years, for 10 years or more, had been working on this, and they had developed ways of extracting nanocrystalline cellulose, and that's just taking pulp and taking it down further to the nano level. So you can envisage molecules that at nano size 10 to the minus 9 meters, and that's about equivalent to, you can look at it as a rectangle of maybe 2,000 glucose molecules. And when you get down to that level, you get some very interesting properties. And we've recently been able to, in the pilot plant, scale this up to kilogram quantities. So we've been able to really start looking at its unique properties and to apply it into different applications. I'm going to talk a minute about that. One is its intense color, much more intense than the usual dyes that are used today. Interesting properties on porosity, depending on its concentration, and its opacity. It can be colorless. And its strength, incredible strength. And a lot cheaper than carbon nanotubes. Some of the applications: membranes for fuel cells, kidney dialysis, protein separation, barrier films that are suitable for liquid packaging. Instead of having Tetra Pak, you know, when you've got the sort of plastic and the aluminum and then the paper, You could actually coat the paper with this, and you would have the barrier that you would need for liquid packaging. You can also make advanced textiles, biomedical devices like heart valves, bone replacements, skin grafts, in cosmetics because of its intense color. It's ultra tough, lightweight composites or biocomposites that can be made from this. And you can see the use on this, on automobile parts. There's a move afoot that we're going to see, and there's a lot of money being put into this, what we call the new biorenewable, the renewable car that has over 50% bio-based. It'll be lighter, it'll be strong, and of course, it'll start meeting the environmental demands that are being imposed on the industry. And we happen to be involved with a group working out of Oshawa, some of the companies, looking and tying it into some of this nanocrystalline cellulose. So we're quite excited about that. Nanotechnology also has other roles. Of course, if you're looking at structures, you're talking fire retardancy, you're talking the issue around durability. These are problems when you build in wood, and if you can optimize that in terms of performance, it's great. Coatings, etc. There's a whole array of things. So in summary, I want to go back to the take-home messages. And clearly to me, that we are moving towards a bioeconomy. And secondly, it's going to be based on lignocellulose. We as an industry have the opportunity to lead on that, or if we don't, somebody's going to tell us to step aside, and it's going to be the Shells of this world and the BPs that are going to lead on the forest. And I think we have a lot to offer in partnership with the energy sector. I think they bring money. They've got a lot of money, and that's needed, capital. But they also bring an expertise and knowledge in terms of products that can be produced that are close, the distribution, etc., of products in the marketplace. And what we bring is a knowledge, a very unique knowledge as foresters on how to handle material, how to do it sustainably, how to harvest that material, how to process it. And it, to me, is a fantastic opportunity for partnerships between two different sectors. So if I was going to end, I'll end on this slide. And it's about the future. It's about sustainability. It's about sustainable forests, renewable energy, low environmental impact manufacturing, and a whole slew of environmental friendly bioproducts and construction systems. Many of you, if you are in forestry, probably started your first job in industry on the green chain. And that is, if you don't know what it is, if some of you haven't, that's in a sawmill, the worst place. That's at the end where the lumber comes off and you sort of are picking it up and moving it on and stacking it and stuff like that. And if you had that as a summer job and you do that 8 hours a day, it's enough to turn you off the industry. But I think there's a new definition of green chain. And it's this new green value chain, and I think there's some real opportunities there. So, with that, thank you very much for your time. It's been a ball. Thank you.
Well, thank you very much.
Oh, thanks.
Well, we have certainly, I think, a lot of material that we're digesting here and kind of the current and future trends for forests. And I think we have some time to entertain some questions. And so we have a microphone we can pass around. And just give me a second. We'll start. Sergio, do you have that hand mic? Or, pardon me. I think we'll have that in a second. Well, that's okay. Anyone with... Thank you.
That graph with the comparison of the wood products for the concrete and the steel, that include the engineered wood products or just traditional wood products?
Which one, I'm sorry?
The bar graph with the wood products compared, the impact of wood product compared with the impact of
Steel and composite.
That is the full gamut, that full range of them. Mostly it would be lumber and it would be panel, and it's based on the idea of a shear wall, so you would have either OSB or plywood as your paneling. flooring, etc. You know how a house would be constructed, rafters, trusses, etc. But there would be, in these now, of course, wood I-beams, etc., and those are considered engineered. And like Silent Floor, if I can name a company like Weyerhaeuser, they're good people. And there's a list of those things. We're seeing more and more now, I would say, oriented strand lumber or finger jointed lumber, etc. So it is a mixture of both, but mostly I would say 90% of it would be non-engineered products, the more conventional ones.
Thank you. Some other questions?
Yes, sir.
What do you mean by third-party certification?
It means that the industry, a company like Weyerhaeuser or what have you, would not be doing their own certification. They would have to have an independent auditor come in and do an evaluation according to a prescribed set of expectations and standards, and that would be the rating. It's quite elaborate. It's a full-size audit. It's like the revenue people coming in, going through everything, your planning of your forests, all the way through to how you harvest, and they're on site and looking at that, and the sustainability practices, how the remedial action of replacing culverts or roads after you've logged an area, all of those things.
Ian, some years ago when I was at U of T as a quasi-Canadian, there was a federal forest products laboratory in Canada and a federal one in the US.
Yeah.
Looking at the evolution in Canada in the management of forest products research, it's rather astounding to see that, since the one in the US looks like the one that used to be there before when Canada had theirs, with very little change. So if someone from the federal government here, maybe not right now, maybe 2 years from now, would come to you and say, what would you recommend we do in the US to create innovation in forest products research? What would you tell them?
Boy, that's a tough question. I will preface what I'm saying is that we have a very close working relationship, collaboration with the Madison lab in particular, and some of the stations, and I see that growing. But if you're asking me what I could suggest, and I'd be quite willing to suggest it, I would first of all say there's some real advantages of going the route of privatization, of recognizing that your paycheck has to come from your customer. But I would say, and that does affect the culture in an organization, it does open up, by definition, a lot of entrepreneurial spirit to try to find ways of getting funding and stuff, because you're forced to in that position. But there are downsides to it. The way we were privatized was the wrong way. It was a very sad event. A politician decided that this was a good thing to do. It happened to be in the days of Pierre Trudeau and his minister. And the staff heard that they were being terminated as government employees by listening to the budget speech and being announced as a government step in privatization. Very bad way of doing things. The other thing, too, that has happened over the years, the downside thing is that we've had to be so focused on the customer because they pay the bills as members, and our funding comes from the industry. We do a lot of government contracts, but most of it comes from the industry. It's forced us into a shorter-term mode, and that has its limitations. What we have done has been very aggressive in building university partnerships. And like in the case of Forintech, for instance, my division, we fund chairs at universities and stuff like that. So we recognize that if we're going to get that creativity on some of the blue sky kinds of things that we can't afford to do, we can leverage it. It's very easy for us to be, as industry, to go to government and funding like NSF in here, but NSERC in Canada, and get leveraging for that kind of funding. So that's worked very well. This new money, this 25 to 30 million that we've got, a large part of that will be to enhance our capacity in-house on some of the things. But let's face it, we're an applied, I'd say mission-oriented kind of research organization, but a large chunk of that will be to feed into universities to tie in. The Sentinel is an ideal project. It's 10 universities. I mean, I don't think the U.S. Forest Products Lab or FPInnovations could hope to get the talent that's there. That group that is doing that work, there are physicists, there's microbiologists, there's chemists. I mean, this whole thing on this bioreactive paper is covered, and all we're there is like sort of experts on paper type of thing and knowing that part on the applied sense. But it's awesome, and the work that is going on and the speed from these universities, 10 universities are networked into this. So I do think I'm talking too long on this point, but I wanted to say that it's not a simple question of privatization. There's different models, but the models have to be integrative. I mean, there's a tendency to have silos. It can be one prof's lab versus another, or one division versus another if it's an institute like ours. And the point of it is, if we can integrate and recognize it's a heck of a lot of fun when you're working with other people that you respect and that can help you achieve your objectives. And so I think this whole idea of pulling people together and working in a focused way, funded well, is the way to go, and this is what we're trying to do. Yes?
You know, your talk about the chemistry associated with lignin and cellulose is quite exciting. But one of the slides, or several of the slides that you showed, dealt with the mountain pine beetle in some of your areas.
Yeah.
I'm somewhat acquainted with that insect, and I suspect unless those areas right now are under management, that for the foreseeable future, they're going to be managed by the mountain pine beetle.
Yep.
And that means that they're going to be killed by the mountain pine beetle, they're going to be destroyed by fire, and then a new generation of large-scale pine, or whatever the species that you have up there is going to regenerate. And all this is going to happen and produce a substantial amount of carbon back into the atmosphere before it's recaptured again by the next generation of trees.
Yep.
So unless a substantial portion of the Canadian forest, if you're talking about, are under some kind of a management, they're going to be managed by the insects and the pathogens out there.
Yeah, that's an excellent point. In fact, one of the early wins for us as an organization, it already started before we merged, was the fact that when the mountain pine beetle occurred, we were able to get an infusion of a lot of money. We wrote what was a comprehensive proposal that covered the full stage of the life cycle of products. So we looked at the fall down, and the idea was the shelf life and the issue on quality, et cetera, what kind of products could be made effectively so that you could try to recover some of that loss because of the beetle. And the engineered wood product piece came in, the whole idea, how do you address in a pulp mill the whole problem around the high with the insect and the stress, the pitch that comes in affecting the pulp and paper production, and all of those kinds of aspects have been and are being worked on. And so there is an aggressive management scheme. It was stopped. It could have been controlled, I believe, at the Tweedsmuir National Park, a provincial park. But environmentalists felt that though that was a park, it was conserved area, shouldn't be cut down. And as a result, the problem got out of control. At the border with Alberta, it's crossed over, but what's happened is that they have a very aggressive using a landscape approach, et cetera, of controlling it as it's in the foothills of the Rockies, and they've been able to contain it this year again. They had a colder winter this past year, and that helped, et cetera. But it definitely is, to me, one of the classic examples of whether it's climate change or whatever, but it's warmer winters that we're having in there, and that's the impact. So we are in a sense managing it, but the problem is, in another 10 years, there is going to be a major shortfall in terms of available fiber for forest harvesting purposes. Yes?
Among some of the people that I deal with lately, there's been a good deal of discussion about the use of small wood for biofuels, specifically cellulosic ethanol and wood pellets, as the means, the most promising means to forest health. Mm-hmm. But I haven't seen that happen yet. We haven't figured out the technologies or developed the markets that can afford to get that material out of the woods and processed. Do you believe that is that's the wave of the future that many people think it is? Well,
there's a couple of issues that come with that. I mean, there's an issue that I think anybody is going to ask is that how much residue can you take out of the forest without damaging its capacity to regenerate, its fertility and stuff like that? And we don't really have good numbers on that. I mean, a lot of it is estimates, inferences, etc. The Swedes have done a lot of work on that area, but their forests are managed in a different way than, let's say, the extensive forest practices we have. But there is an area around that has to be addressed. We believe that we're leaving over 60% of the biomass in the forest, and most of that could be removed because you've got the litter, but you've also got roots, et cetera, that will stay and through that process. And the problem is, and this is the work that our engineering people are doing, it's the whole, how can you economically move it from one place to another, concentrate it to be able to process it either in ethanol, biogas, or syngas, I should say, and various things. And that, what we're looking at now is it possible to be moving in small units that can generate maybe 4 kilowatt or something, smaller unit that could be tied into communities and stuff like that. There's a couple of companies that our guys are working with in terms of looking at that. So it's not necessarily having to move it to a large facility. It might be to use it locally and sustain community.
To move this facility to the wood. Right?
Yeah, exactly. Now, we used to burn a lot on the roadside, as you know. I mean, there's a lot of residue as you forward out, you know, your material, and you cut to length on the roadside. You leave a lot there, and a lot of it was burnt. So, I mean, the point is that that's not helpful. There's got to be ways of making better use of it.
We've got a question in the back. We're going to.
Yeah.
Yes. Could you compare the intricacy, complexity, or capital intensity of the new cellulose technology compared to what we associate with a pulp mill?
Yeah, the one that I had as a picture there, you're talking about maybe 400 to 500 million for the larger facility, but I don't think one has to go that way. That's a greenfield. I think some of the opportunities, and I've seen personally experiences of this, is you use the concept of a bolt-on. You recognize that making pulp is legitimate, but you want to have a diversified stream to maximize your streams. And a lot of mills are looking at bolting on a capacity to do this or that. So you're actually building it as a cluster around the site. One good example with that would be Tembec up in Temiskaming. I mean, they're making biogas, they're making lignin, they're making a whole array they're making ethanol, second largest ethanol producer from wood in Canada. And they're doing an array of those things. And that operation wouldn't be there if it relied solely on pulp. In fact, the only thing making money these days is these other things, not the pulp side. Yes?
Is there similar attention in Canada to research for petroleum or metals?
Yeah. I think the success story I could look at in petroleum was the tar sands, the technology to develop to be able to extract that. Now they're using carbon injection or CO2 injection as part of the processes, so there's a lot of research. The companies like the Shells, they're spending a lot of money. And I mean, that's the problem on the forest side, as we know. Companies are not necessarily that amenable to be investing in these kinds of things. And that's a big disadvantage. And that's why I think we'd be better off to partner as much as we can with some of these companies, because they're going green. I mean, it's renewable. I mean, wind power, et cetera, various options. In terms of renewability, whether it's Shell or whether it's BP, et cetera, they're heavily investing into these other areas. The thing interesting in Canada is it's publicly owned land. And when I talk to people within government, there's also a tendency to say, look, we've tied this land up through tenure, et cetera, to certain companies. These guys aren't being as progressive as they should be. Maybe we should take it back from them and give it to the Shells and the others and let them use it to better use, which is scary. So, I mean, you know, it's almost like use it or lose it type of thing. And I go back to my point. I think it's a gold mine. I think what we bring to the table, that we could help these Shells and these BPs, is a knowledge base about this forest and this fiber, et cetera, that could be very useful. They know boom all about that side of the business. And so there's a real opportunity. So in terms of your question, yes, a lot of investment is going on that. Minerals, well, that's now, forest used to be the #1 export in terms of Canada. It's dropped to 3. Energy is #1, and minerals is #2. That, by the way, I'm digressing, but I can't help but say it. I believe that, you know, 3 years ago, the Canadian dollar was 62 cents. And it's now $1.02. And you know, a lot of people will say it's because the US dollar has gone down for various reasons. But I believe the fact that you've got this humongous natural resource and the world is crying for it. I mean, potash, shares in Potash, Saskatchewan, we're at about, I think, 25, 30 bucks. And then dropped, and I got out, I had some, and it's gone up to 200. And I don't think it's a bubble like we saw before, but this is serious stuff and long term. And so I really do think that we have to look at it from a global North American perspective. I think there's some things that could be done quite excitingly, and hopefully that's what's going to happen.
So let's get some student questions.
Yeah, great.
All right. Let me hand you the microphone. Thanks.
I was just wondering how much from the, you had the white powder, the nanocrystalline cellulose, like how much do you get that from a normal tree? Like how much, what's the ratio, I guess?
Well, you don't, when you're processing it, you process, I don't have the numbers on the technical side of the pulp, but I mean, it's going to be once you get to the pulp recovery, and of course, obviously, you're going to have several streams that go out, and so you're going to have a reduced level. And I don't have the number. Maybe somebody in the room does on what the recovery is from let's say a ton of wood fiber. But this is processed down. It's harshly treated, acid treated. It's broken down. And again, the recovery on this, and it's more the optimization of the process, but in a day, the pilot mill will make a couple of kilograms. But I mean, you know, in terms of the value, I mean, you're talking about what? You're talking maybe 50,000 a gram or so. I mean, you know, it's expensive, you know, at this stage. You know, if you're going to use it for some of the specialty stuff. It's being used now. We're working with a food company, and it's being used in drinks as a fiber additive because at whatever concentration you use it, it's colorless. So you add as a fiber, you don't get turbidity and stuff like that. And so people want a drink that has a fiber content. It's that kind of stuff. It's not huge markets. Somebody said you would run a pulp mill for maybe 30 seconds to get enough to supply something like this. So it's not to move. However, if you look at it from a composite in terms of auto parts and things like this, that would be in biocomposites, that would be using a lot more material. Yes? Sorry.
Since you're from Canada, I decided this would be an okay question to ask, but I'm interested in industrial hemp. And since it's high in lignocellulose and 1 acre of industrial hemp produces 4 times the amount of paper than trees do you see it having a role in the new bioeconomy?
Yeah, I think there's a whole array. I think whether it's hemp or whether it's fiber from lignocellulose from agricultural crops, I kept saying forestry, but I should also be saying ag residues. It is important. In fact, it might be used as an energy source, but for me, lignocellulose has better uses. We've made what looks like an OSB board using corn stover, for instance, as a lignocellulose, as a stover material, which has better properties, actually, Frank, stronger than aspen-based OSB from trees. It's an incredibly neat product. And this is done with Rob Wellwood at the ARC, Alberta Research Center. But in answer to your question, yeah, I think that's being open to look at a wide array of things, and that's what's happening. I think in the agricultural areas, on the prairies, for instance, in Canada, or even in the US, Montana, and those areas, they're looking at a wide array of energy crops, but also fiber crops in terms of end use and applications. Flax being a notable one. Yes? Oh, I'm sorry.
Oh, okay. So you mentioned about like extensive management of forest.
Yeah.
But like I think the forest is not that straightforward like industrial product or just crops. So like there's a lot of uncertainty for the future management. So do you have any idea for that uncertainty?
Yeah, and I think that you're right. There's a very strong dimension that goes on the multi-values that I was trying to allude to, like biodiversity, all of these things. We've got to respect. There's no question. And some of it is respected by conserving and not touching it at all. But there are other areas that I think you can manage for multiple values. There's integrated forest management. There's landscaping approaches to harvesting. There's various ways to leave the softest environmental footprint and respect the fact that it's being shared, whether it's animals or biodiversity or other people. And I think that's important. I think the advantage we have, I look at it with the extensive approach, is that it's a much softer footprint, much less energy intensive than perhaps highly managed or plantation kinds of forests. I mean, I've been through bamboo forests in China. I mean, you know, you walk through, there's not a lot of biodiversity in there. You know, and I think that, that this becomes an issue. Yet, I've been north of Beijing, and I've seen the mixed plantings that they've done on that to stop the sand dust that comes into Beijing during the windstorms, and that's been quite successful. And they're mixed forests and stuff, and you're seeing a lot more biodiversity, a lot more healthier kinds of approaches.
I think we're going to do one last
Yeah,
question. And Larry?
Yeah. Is a lot of the stuff that you're doing, particularly in the nanotechnology and the chemical fields and the paper fields, is that being publicly reported, or is it basically an in-house?
No, it's yeah. Most of that is being done with universities. It's public. It's being published.
Okay. Thank you.
On the nano, well, not the nano, Sentinel, the bioreactive papers. Actually, the guy that's leading the group is Pelton, Bob Pelton out of McMaster, and as I said, there was 10 universities here.
Well, I want to thank Ian for sharing his vision, which is quite extensive, forward-looking, and also the passion. You can see that he has about forestry and forestry issues. I invite you all to, if you would like to stay after, maybe chat. But at this point, why don't we have a small round of applause for our guests. And
Thanks.